This is problem number 1 from section 4.5. It says the graph and degree of a polynomial with real coefficients, f of x, are given below. Determine the number of real zeros and the number of imaginary zeros. Assume that all zeros of f of x are distinct. All right. They tell us degree 2. That's an important piece of information. There's a few theorems that we need to discuss. First of all, we need to discuss what's called the fundamental theorem of algebra. So the fundamental theorem of algebra states that a polynomial f of x of degree n with n greater than or equal to 1 has at least one complex zero. So all that means is if you have a degree 1 polynomial, degree 2 polynomial, degree 3 polynomial, they are at least going to have one complex zero. Now, when it says one complex zero, keep in mind the complex number system includes real numbers. So it doesn't mean that it's an imaginary number necessarily. It just means that it's at least one number in our number system. So I'm going to write that, I'm going to put that up there. The second one that's important is the number of zeros theorem. So the number of zeros theorem says a polynomial of degree n has at most n distinct zeros. Meaning if you have a degree 1 polynomial, it has at most 1 0. Well, that makes sense. Linear lines have degree 1, they only cross the x-axis once. Degree 2 have at most 2 distinct zeros because, again, a quadratic is going to cross the x-axis twice in most situations. Same thing for cubic, fourth root, so on and so forth. So it's just telling you that the degree of that polynomial is the most amount of zeros that you can possibly have. And then finally, we have this conjugate zeros theorem. It says if a polynomial f of x has only real coefficients, which in our case they said real coefficients up here, and if a plus bi imaginary number, is a zero of f of x, so you have an imaginary number that's a zero of f of x, then the conjugate a minus bi is also a zero of f of x. So this is a long sentence just telling you that imaginary numbers come in pairs. So if you find that you have one imaginary number, then you actually, one imaginary number as a zero, then you actually have two imaginary numbers as a zero, and the conjugate of the one that you got is the other imaginary zero. So no matter what, if you find one imaginary zero, there's a second one out there. So these three things are very important. Now we're going to forget about these top two. Those are just kind of to define the whole thing. But this conjugate zero theorem, this is an important one for looking at this problem here. So it says the graph and degree of a polynomial with real coefficients f of x are given below. They tell us it's degree 2. They want us to determine the number of real zeros and the number of imaginary zeros. We'll look at our quadratic. Does our quadratic cross the x-axis? If it doesn't cross the x-axis, then in our case we have no real zeros. So if we don't have any real zeros for this quadratic, then that means we have at least one imaginary zero. But we can't just have one imaginary zero. We actually have to have two imaginary zeros. And remember, degree 2 tells us we can have up to 2 zeros. So this has no real zeros, but it has two imaginary zeros. And so that was a lot of talking to break down a very simple concept. If you look and you see that you don't have any real zeros for a degree 2, then you got two imaginary zeros there.